Alright, so you want to learn the code. The code editing software I use is called CodeBlocks. I've been using CodeBlocks for about a year now. And within that time, there's been a few projects I've been proud of. The first few have been like within class, I had a encryption program that I further expanded upon, and a battleship program that I also further expanded upon. So those two programs were like heavily modified from where the class left it off from. And then the other two have been a ball animation, that's just a prototype to show that I can do animation within C. And then the other one has been a Space Invaders prototype that simply just shows the gameplay mechanics are possible within C. I'm hoping to share some simple basic stuff through a series of videos, and this video is going to be starting out with this very basic structure and a simplified overview of the different components that you're going to be using for the most part in almost everything you do. So to start off, every program has what we call header files. Header files are basically a dictionary that is used for translation from the human code to a computer version of that same code. So in order for the computer to understand what we're writing in code, we need to include the proper header files. So to include these header files, we simply just have to do a pound include. And you're going to do a less than sign, and you're going to do standard IO, it's going to be the first one, so std io.h, and the .h stands for header. So standard IO is the first one, and the next one you're going to be using is going to be the standard library, so std lib.h, and you're going to do a greater than symbol to finish it off. The next thing you want to be sure to cover is going to be global constants. Global constants go below any header files you have, and global constants, you can think of these as like things in your code that will never change. They are fundamental laws in your code that will never change, because when you make a global constant, you can't change it like anything else you can change, like variables, which we'll get into in a second. Variables are things you can change. You can manipulate what they represent and what values they hold. But global constants do not change. They are constant factors that will forever be constant, hence the word. Now the global part of global constant is in the sense that they can be used globally in the program, and we'll cover that in a little bit. Below global constants, I like to put my function declarations. And function declarations are pretty much just telling the computer, hey, I'm going to be making these functions later on in the program. This is just a heads up. That's how I think about it. And we'll be covering functions in a much more in-depth video later on, but just for right now, this is where you would put function declarations. Below function declarations is where I like to put my global variables. Now global variables, just like global constants, can be used throughout the entire program on a global level. So any function can use a global variable. So global variables are a value that can be changed and manipulated, hence the word variables. It can vary based on what it is, what it can be, and what you can do with it. So they are all forever changing whenever you need it to be. In contrast, global constants are things that do not change. They are constantly one thing, while variables are a variety of different things that can change form, shapes, values, weights. So global constants and global variables share one thing in common. They can be used throughout the entire program within any function. And I'll get more into that in a little bit. So below the global variables, I like to put the main function. And the main function is where your program essentially starts, where the actual instructions for what you want the program to do will begin. Now from there you can branch out into other things, other functions, and we'll get into that in a second. Now to create the main function, you're going to do an int main, and you're going to do empty parentheses. Below that, I like to put open braces like this and return 0. And then right here is where I would start the code. Some people don't like having the braces like this, and another way they do it is by having the braces up top and splitting it up like this. So this is also valid right here. So this is your main function, and we now have a working program that returns the value 0. So whenever our program finishes, it will return this value 0. And when we can see that programmatically by hitting the compile and run button, and as you can see right here, it is returned 0. So it gave us back a 0. Now we can change this value to be anything. We can make it a 5, for instance. And when we run this program now, you can see that it gave us back a 5. A 5 was returned. So that's what this is doing, okay? And just know that your program, your main function, will always look like this in the beginning. Another important thing to always keep in mind, most lines of code, not all lines of code, but most lines of code need to have a semicolon at the end. So this return line right here, this is like an instruction per se. Not all instructions need to have a semicolon, but most do. And as we get into more videos, I'll be pointing out which ones do and don't need semicolons. But for the most part, keep in mind that most lines need semicolons, and the return command is definitely one that needs a semicolon. If I were to not have a semicolon here, this program would not compile. There would be an error because it sees there's a return command. It's kind of like the computer's like looking at all this information, and it's going, and it's not ever seeing this command, this semicolon, to tell it to stop looking. Because the computer's looking for the semicolon, if it ever finds it, it's not going to know what to do. It's expecting the semicolon to exist, and if it doesn't exist, it's not okay. So the computer does not like it when semicolons do not exist. So whenever you get errors and such like that, code blocks at least gives you pointers as to where errors are. Like right here it says line 14. So on line 14 it was expecting a semicolon, but it found a brace, and the brace it's supposed to have a semicolon before the brace, so it's kind of confused. So line 14 is the error, but in actuality the issue is up here on line 13 because we don't have a semicolon. So we can tell that. So when there's an error down here, we look at this brace, we're like, well, the brace is fine, that's all good. So we go up a line, and you can see up here, like, oh wait, there wasn't a semicolon here. So when the semicolon's in place, everything can work appropriately. Okay. So below the main function is where we like to put any additional functions. And one thing to keep in mind is that additional functions actually coexist. They coincide with function declarations. The main function is an exception. The main function does not need a function declaration, but any additional functions require a function declaration. Now, I say required, but required is a loose term. They don't need a function declaration, but you will have issues by not having such. Okay, I'll give an example right now. I will create a void function called, let's call it math. We'll give it an empty parameter list. We'll put brackets. So yes, the program will run because it doesn't need the function declaration, because it doesn't really care for the most part. But if we were to do a function call, okay, and I'll get into this more details later in a different video, but a function call is when you want to exit one function and go into another. So like I said initially, every program starts in the main function. It starts here, it starts at the top, and it works its way down to the bottom, where it will find return 0. Okay. A function call is a side path. Kind of think of it as the main function being the main quest, and any additional functions being side quests. It has to continue to beat the game, the main quest, but it can, while it's beating the main quest, explore side quests whenever it wants to. So in this instance right now, when we run the program, it simply just finishes out the main quest. But I wanted to go check out the side quests too. So my side quest is called math. I have a function down here called math. It does absolutely nothing at the moment, but I wanted to do it. I wanted to explore this empty void math function for fun. So if I put the word math, the function name math, and put empty parentheses, it will work. I will also need to have a semicolon here. And if I run this, you'll see I get a bunch of errors. But the program runs. So I got a bunch of errors down here, a bunch of warnings. But it still worked. I still returned 0, which matches up with what my program does. The reason why it has issues down here is because we did not declare a function declaration. The computer understands what we did, but it likes a heads up. It likes to be told, like, hey, I'm going to be making this function. It's going to be called void, math, and no parentheses, no parameter list. It's all good. So the way to work around this is simply just put a void math, empty parameter list. at the top with the function declarations. So when we run this now, we won't be having any errors and our program still works. So that is the bare basics of a program. This is just meant to be a quick overview. I don't want to bombard people with a lot of information, but going forward into other videos, we're going to be covering a lot of this information more in depth, and I'm hoping this helps build on your knowledge as well as my own knowledge. I'm still learning this stuff myself, so this is a great way for me to stay refreshed, but I'm hoping to actually teach people going forward the things I know, because I find this stuff very enjoyable, but it does become a lot. So until next time, keep it going.